Hello, Pikachu. How are you today? I hear you want to learn more about electrons. Pika, Pika. All right, well, my good friend Mrs. Bush knows all about electrons. Pika, Pika, Pikachu. Hello. I didn't fool any of you for a minute there, did I? All right, so let's talk about electrons. First of all, let's determine how do you figure out how many electrons are in a given atom. Well, when we talk about atoms, if we have an atom written like this, let's review. What does the 11 mean? It's the atomic number, so that is equal to the number of protons. Okay? We know that this guy would be protons plus, that's right, neutrons. Mass equals the mass number. And the value that's up here is our charge, and that is equal to protons minus electrons. So if we have no charge, guess what? 11 protons minus 0 equals 11 protons minus how many electrons? 11. So, if it's a neutral atom, we can assume that the electrons and protons are the same. Where do you find the atomic number? On your periodic table. All right. So today we're going to learn, where do the electrons really live? Well, let me tell you where they really live. We all know from grade school at some point we learned that electrons are out in the outside orbiting the nucleus. So the electrons are orbiting, and Niels Bohr, early 1900s, determined that they orbit in specific areas or energies, and that it takes a certain amount of energy to jump from one level to the next. If you don't have that energy, it can't jump. It's going to stay where it was. If you have the energy, you can make the jump. And then when you fall back, when it comes back to the original state or the ground state, it releases that energy. So we know they're out there in and we've talked about that. But where in those energy levels are they? Now, sometimes you'll hear it called the electron cloud. That's because really it's all probability. We can't know where the electron is and how fast it's going at the same time. So we just have probable places that it could be. And so this is what science has come up with, using that information of how much energy it takes to move between energy levels that's given off as light. We've come up with the following model. All right, and we are, in order to learn this model, going to go visit the Aufbau Hotel. The Aufbau Hotel is a convention hotel. We have a few rules. It's customer focused, meaning we start at the lowest room price and build up. So if you've got a cheaper room available, your guest goes there. All right, Manager Polly says each room can have 2 electrons. If you have more than 2, not going to happen. So if you've got 2, you're full. In addition, in the room, there's 2 beds. You've got to have 1 electron sleeping in a bed with his head facing the doorway, and the other in the room facing opposite the doorway. All right? So they're not sleeping both heads up. One's heads up, one's heads down. Okay? Manager Hund says that electrons spread out to become more stable. So you don't double up hotel rooms until you have to. At some point you will have to double up. All right? I like to think of it, because we're talking about the hotel thing, that maybe Hund has a thing against the cleaning staff, and he wants them to have to clean as many rooms as possible. So if there is available rooms at that price, you do not double up until you have to. All right? First of all, smoking rooms are nice, regular rooms. They smell, actually they're really not that nice. They probably smell like smoke. There's not necessarily even a window. It's just a regular room. The next type of room is the premium room. Now you notice that first one was round. These are all peanut shaped. Okay, there's 2 lobes. Okay, the third type of room is a double peanut. This is a even more expensive room. Balcony, has a mini bar. And the last type of room, the fabulous room, you get a suite, you get a balcony, you get a full bar, you get a hot tub, and a masseuse to come give you massages whenever you need them. So our first convention comes to town, and it's the Hyacinth Convention. We have one guest. Where are we going to put him? Well, Hund's rule, or Aufbau's rule says start at the lowest room available. So he goes into the first level smoking room. The Hells Angels Convention comes, and we have two guests. What's the rule? We start at the bottom. We go in the first level, and we have to sleep one guy's head up, one guy's head down. Okay? Next convention, the Berry Growers Convention. Now we've got four guests. Again, we start at the cheapest room. There's still room in cheap rooms, so we put a second one in there. Now, we can't put any more in. It's full. So we go up to the next energy level. The cheapest room here on the second floor is a smoking room. So we go ahead and put one guy in there. And since the premiums are more expensive, the other guy also goes in there. Now, furthermore, we're going to learn a code because the fire department wants to know who's got rooms, which floor has which rooms occupied. So, this is on the first energy level. Oops, not a P. First energy level, S2, because the smoking room has two people. Second energy level, the S room has two people. Okay. Next, the bowling convention has 5 guests. Once again, you guessed it, we're starting at the bottom. 2 guys in the smoking room, 2 guys in the second floor smoking room. Now we have 1 guy left over. He gets to go to a premium room. Okay? He would be written 1S2, 2S2, 2P1. So we don't necessarily know which particular room, we just know that there's at least 1 guest in the premium rooms. The Carver's Convention, 6. We have 1, 2, 3, 4, 5. Now, Hund's rule says we don't double up until we have to. So where am I going to put this next electron? Is he going to go in here with this guy, or are there additional rooms? You're right, there's additional rooms. So he goes here. 1S2, 2S2, 2P2. The Neo Fan Club, 10 guests. We're getting bigger fan clubs now. 1, 2, 3, 4, 5, 6. That was the Carver. That's where we put all the Carver people. We've got 4 more guests. 7, 8, 9, 10. 1S2, 2S2, 2P6. Now, in your note section, there is a sheet. The sheet actually looks like this, but it's similar to what I'm using. Feel free to take that sheet out of your notes, stick it into a plastic sleeve, use a Crayola marker on it, and you can write and wipe on at your discretion to help you with plotting these in. I will have these available for you should you need it in class. Our next group, the Police Action League. We have 15 guests. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Anybody notice anything? Yeah, I did that wrong, didn't I? On purpose. 13, 14, 15. Really, they don't double up because of Hund's rule. So we end up with 3 half shells. Now, I keep saying Hund doesn't like the housekeeping staff, but really, a half shell is more stable. If you have all your half shells half filled, it's more stable than 1 full shell and 2 half shells. All right. Final convention, the Brokers Convention, 35. Now we got a lot to go. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now, did anybody notice an anomaly there? We had the 3 smoking rooms. We had the 3 premium rooms. Then we went to 4th floor and filled smoking rooms. That's because the smoking room on the 4th floor is cheaper than the deluxe room back on the 3rd floor. So now the electrons, after they filled here, had to run back down to the 3rd floor and fill that deluxe room. Okay? It actually starts out that that electron cloud, that 3D cloud, is a little bit bigger than the 4s. So it's the 4s is lower, and then as electrons begin to fill into it, it drops down back into the 3rd energy level, and 4s is definitely larger at that point. All right, so far we've got 30 electrons. We got 35. So we need to put in 1, 2, 3, 4, 5. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. Now, that's not too bad right now, but as we get into bigger and bigger elements, that's going to be a lot of letters to write. So we can do a shortcut. Let me show you how we want to do the shortcut. I have my handy-dandy pictures. And here is our favorite periodic table. And you'll notice that the periodic table has rows. Those rows are called periods. Here is, well, he's off the edge of the screen, sorry. Here is bromine. Bromine. Right there. He is in the 4th energy level. So it's not quite full yet. If you want to do a shortcut, what you're going to do is you're going to go back up to the 3rd level, come all the way over here to the right. Argon, we see, is the end of the 3rd level, and you can use argon as your shortcut. Argon. So let me show you how this works. Let's actually do a electron configuration for argon. We'll just use our sheet here. All right, argon has 18 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, the code 1s2, 2s2, 2p6, 3s2, 3p6. So, take a look at that code. I'm going to copy it, and I'm going to go back to our other page and paste it. What's it look like? 1s2, 2s2, 2p6, 3s2, 3p6. So I can actually, for my shortcut, drop all of that part out. Why is this not showing up? We can drop all that out and we can substitute argon in for that. So the shortcut for bromine would be argon 4s2, 3d10, 4b5.